Good morning, everyone. Thank you for joining us today. So, in our last deep dive, we really mapped out the factory's nervous system, right? That whole deterministic world of PLCs and SCADA that runs automation with just incredible precision. Now, these systems, they're the absolute bedrock of industry, but they follow the rules we give them. They execute commands flawlessly, but they're rigid. Today, we're taking the next big evolutionary leap. We're asking, what happens when we introduce a little bit of a ghost in the machine? When we give these systems the power not just to do, but to learn, to see, and to adapt all on their own. We're talking about that spark of intelligence, artificial intelligence and machine learning, the technologies that are finally giving automation its brain.
So here's our game plan. First, we're going to tackle that fundamental shift in thinking, moving away from hard-coded rules to something way more dynamic, something that can learn. Then, we'll get into the three incredible gifts that AI is giving to automation: the amazing gift of sight, the strategic gift of foresight, and the truly revolutionary gift of adaptation. And finally, we'll tie it all together to really get what it means to build automation's brand new brain. Let's jump in.
Okay, so this first section, it's a big one. It really sets the stage for everything else we're going to talk about. We're not just looking at machines that are a little faster or a bit more efficient. No, we are talking about the dawn of a completely new era, a fundamental shift from machines that are just programmed to machines that are genuinely intelligent.
And this slide just nails the difference. On the left, you've got your traditional deterministic automation. The train on the track. It's the perfect metaphor, right? It's super fast, super efficient, as long as everything is perfect and nothing ever changes. But the second something unexpected happens, a rock on the track, the whole system just breaks. It's brittle. That's the problem with trying to program for every possibility. You just can't. Now look at the right. That's intelligent automation. It's the all-terrain vehicle. It has sensors, its eyes and ears, and a learning model for a brain. It's not just following some pre-drawn map. It's actually seeing the terrain, adapting its path, and making its own map as it goes. We're moving from brittle logic to resilient intelligence.
And this quote just brilliantly sums it all up. AI and machine learning, they aren't just some small upgrade, like a faster chip. They are that spark of intelligence. It's a catalyst that completely changes what the machine is. It's the difference between a simple tool and a real partner, between a puppet and something with agency.
All right, with that foundation laid, let's dig into the first of AI's incredible gifts, the gift of sight. You got to remember, for decades, industrial robots have been these incredibly powerful but, well, effectively blind machines. They're stuck in safety cages because they have no idea what's going on around them. AI-powered computer vision is what's shattering those cages, letting machines finally perceive, understand, and navigate our messy, complicated world.
And that brings us to a really important question. Machine vision isn't a new term. It's been around for a long time. So what was the problem? Why were the old systems so limited? And what was the big breakthrough that let AI finally crack the code?
Well, the answer is this beautiful piece of engineering inspired by our own brains, the convolutional neural network, or CNN. See, old vision systems were fragile because a human had to literally write code for every feature, like look for a perfect circle of pixels. But what if the lighting changes or the angle? The rules break. A CNN works totally differently. You don't program it with rules, it learns. You show it millions of labeled pictures, and its layers start to figure out patterns on their own. The early layers learn simple things, like edges and colors. Deeper layers combine those to see textures and shapes. Deeper still, they see parts, like an eye or a wheel, until the final layers can recognize the whole object. And this process is what gives it the power to generalize. It's not just matching pixels anymore. It's understanding the concept of a cat or a defect, which is why it can spot them even in situations it's never seen before.
Okay, so with this amazing new ability to generalize, what kind of things can machines do now? Let's look at a couple of really advanced tasks that go way beyond just recognizing an object and move into true scene understanding. So on this slide, we've got two total game changers. Up top, semantic segmentation. This isn't just drawing a box around something. The AI model is classifying every single pixel in the image. It's building this super detailed map of reality. This pixel is conveyor belt. This pixel is product A. This one is human hand. That level of understanding is absolutely essential for things like a robot trying to grab an object in a cluttered bin. Then you have AI-powered quality control. Think about high-end manufacturing, like aerospace or microchips. An AI can scan an image and spot a microfracture on a turbine blade that's completely invisible to a human, even with a microscope. And it does it with superhuman consistency, 24/7, without ever getting tired.
Now, when you put all these capabilities together, you can solve what was, for decades, kind of the holy grail of robotics, the bin-picking problem. Sounds simple, right? Just pick a specific thing out of a jumbled pile of other things. A 5-year-old can do it, but for a traditional robot, it was basically impossible because of the infinite ways objects could be piled up, rotated, and blocked from view.
And here's the modern solution in action. Imagine a warehouse. A robot arm swings its 3D camera over a bin. Then, in less than a second, this whole symphony of AI models just fires off. Step 1, capture a 3D point cloud and a color image. Step 2, a model detects and classifies everything it can see. Step 3, another model figures out the exact 3D orientation of the object it needs to grab. Step 4, yet another AI calculates the absolute best, most stable place to grip it. And finally, a motion planner figures out a smooth path to go in, grab it, and get out without hitting anything. This whole complex dance happens in the blink of an eye, thousands of times an hour. It's incredible.
Okay, so we've given our machines the gift of sight. They can see the world around them. Now, let's move on to the second gift, foresight. This is all about turning that perception inward, giving a machine an awareness of its own health and the ability to predict its own future.
This brings us to a concept with massive value, predictive maintenance, or PDM. In a factory where 1 hour of unplanned downtime can cost $1 million, the ability to predict a failure before it happens is an absolute game changer. So, what is this strategy, and what's the tech that actually makes it possible?
This timeline really puts it all into perspective. You know, in the past, we had reactive maintenance, which basically means wait for it to break. It's pure chaos, super expensive, and disruptive. So then we got smarter and moved to preventive maintenance, servicing stuff on a fixed schedule, like changing your car's oil every 3,000 miles. It's better, but it's also really wasteful. You end up replacing parts that were perfectly fine. The future, driven by AI, is predictive. It's not based on a calendar, it's based on the actual real-time condition of the machine. You do the maintenance at the exact right moment, not too early, not too late.
So how does it actually work? Well, the key idea is that machines almost never fail silently. There are always these little warning signs, these whispers in the data, that something is starting to go wrong. So step 1 is data collection. We cover the machine in IoT sensors, vibration sensors, thermal cameras, microphones. This fire hose of data streams in constantly. Step 2 is training the model. We use tons of historical data of the machine running, both when it's healthy and when it failed, to teach an AI what normal looks like. It learns to connect a specific vibration pattern to bearing wear or a certain heat signature to a coolant leak. And step 3 is the prediction. The live model just watches the data stream. When it sees a pattern that deviates from that healthy baseline, it doesn't just raise a flag. It can actually estimate the remaining useful life of that part.
This is all really cool technology, for sure. But what about the bottom line? What's the real-world business impact of being able to see the future like this?
And this quote just says it all. In a big factory, unplanned downtime can cost hundreds of thousands of dollars per hour. The old way was getting a panicked call at 2 a.m. that the main line is down. The new way is getting a calm, automated alert like this one, maybe days in advance. And look at how specific it is. It's not just a vague warning light. It's truly actionable intelligence. It tells you the problem, the probability, and a time window. This completely transforms maintenance from a chaotic emergency into a planned, scheduled, efficient activity.
So, we've given our robots sight to see the world and foresight to understand themselves. Now we get to the third, and honestly the most profound gift, adaptation. This is where we go beyond just learning from data we've already labeled. This is about creating machines that can learn brand new skills all by themselves, just through trial and error.
And the technology that unlocks all this is reinforcement learning, or RL. This is the same type of AI that mastered the game of Go, that powers some of the most advanced AI agents we have. So let's break down what it is and how it helps us get to that ultimate goal of a truly adaptive robot.
This slide shows the crucial difference. The computer vision stuff we talked about, that's supervised learning. We give the AI a giant data set with all the answers in the back of the book, an answer key, and it learns to match questions to answers. Reinforcement learning is totally different. There is no answer key. The AI agent, the robot's brain, learns by doing. It's in a situation, it tries an action, and then it gets a reward or a penalty. Positive reward for stacking a block, negative reward for knocking the tower over. After millions and millions of these little experiments, it doesn't learn a set of rules. It learns a policy, a strategy for picking the best action in any situation to get the most reward over time.
Now that sounds great in theory, but you can't just let a multi-million-dollar robot arm flail around for months hoping it figures things out, right?
That would be slow, expensive, and you'd break a lot of robots. So how do we actually make this work in the real world? How does this learning method lead to the breakthroughs we're actually seeing? Well, here are 3 amazing examples, and the first one is the key, the sim-to-real pipeline. This is the genius hack that makes RL practical. We build a super realistic physics simulation of the robot and its world, a digital twin. Then, the AI can run through millions of trials, years of practice in just a few hours inside the computer with 0 risk of breaking anything. Once it learns a good policy, we just transfer that brain into the physical robot. This is what enables things like general grasping, where a robot learns a universal strategy for picking up things it's never even seen before. And of course, this is the secret sauce behind the incredible agility you see in those Boston Dynamics robots. That amazing fluid balance, it's not programmed. It's an intuition for physics that was learned through countless failures in a simulated world.
All right, we've gone from perception to prediction to adaptation. We've seen how AI is giving machines sight, foresight, and the ability to learn for themselves. So let's bring it all home. What is the one big, key takeaway about what AI is doing for the future of automation?
And this is it. AI and machine learning are giving automation its brain. We are seeing this fundamental shift from deterministic systems that just follow a script to probabilistic systems that can actually perceive, predict, and adapt when things get messy and uncertain. The winning companies of tomorrow won't be the ones with the most steel, but the ones with the smartest algorithms. We are moving from a world where we build tools to a world where we're actually creating partners. And, that raises a pretty fascinating question. What happens when these new, intelligent partners start working right next to us on the factory floor? We're going to explore exactly that in our next deep dive and explain what we're calling the new coworker, how cobots are working beside us. Thank you so much for joining us today. Be sure to subscribe to our channel, Tech, AI, and Beyond, so you don't miss a thing.